Hey, how we doing? I didn't have the microphone switched on then, but we're on. We're on. How's everybody doing? This little hearts thing, I don't know what that's all about. It just pops little hearts and hundreds and all sorts of stuff up. Right. Anyway, how we all doing? Let's catch up with everybody. I think I said hello to a couple people earlier, but Timothy's in. I know. Where are we? Hi, Timothy. Aaron's in from pretty horrible Penzance, by the looks of it. It's pretty horrible here. It's hammering down with rain. It's not very nice. A lot of wind as well. Who else have we got? Derek's in. Check down on the Isles of Scilly. Hello, 80. Hot and humid in Spain. You got the good weather over there then, by the sound of it. Afternoon, Dwarf. Matamley, hi, Joe. Who else we got? We've got Nick in. Hi, Nick. Petronics. Rob Titheridge. Hi, Rob. Mike Cass. Hi, Mike. Bob Anderson. Chris Milky. Hi, Chris. Andrew Littleboy. Hi, Andrew. And Luigi. Hi, Luigi. Les is in. Been released from the grandkids today. Ben Humphries. Hi, Ben. Hang on, it's jumping. It's jumping. Simon, how you doing, Simon? And Russie B, how you doing, Russ? Thomas Kitts, Tom and Susie, hi. Carther, David Tipton. Oh, the man with the very new winding machine, David. What a fantastic bit of kit that is. I'd need a month to learn how to use that thing, I think. Hi, Gavin. I'm talking about David Tipton's latest video, by the way, so if you haven't seen it, then after the stream, pop over and have a look. How you doing, Gavin? Peter Carter. Hi, Peter. Bruno. Hi, Bruno. And John Hood. I wouldn't say we're better, John, but I would say we're a lot better. we're a lot better than we were. I've still got this blimmin' cough that don't seem to want to go. A bit of a sore throat still, but I'm feeling better than I was, I can tell you. That's pretty rough. Hi, Sandra. Yeah, we've got a weather alert here and all sorts of stuff going on the computer. Yeah, released. So, what have I been up to? So Les came over yesterday and we had a bit of a brainstormer of a session on the SW55. And we've made some progress, some good progress. So I'll run over that in a second, but I've got to find the schematics first. Should let me restore it from last week. Okay, right, let's just catch up with the chat again a minute. Hi, John. How are you, John? Hopefully we've got a chance to have a look at some of your bits and pieces today. Yeah, it just won't go away, David. It just will not go away. It will not go. I mean, I must be 4 weeks now for me, and Mrs. Cruncher's had it a couple of weeks longer than me, 3 weeks longer than me actually. She's still not great, but we are better than we were, so can't complain, can we? I've worked through it as well, so got to be done, isn't it? Sorry to hear you haven't been well either, David. Hopefully you're on the mend as well. Jackman's honey and lemon lozenges. Yeah, but that makes the beer taste funny, Gavin. That's the problem. It makes the beer taste funny. Hey, welcome, Robert. How are you? So I've managed to get Chris Milky's 2 radios sorted now, all finished, all back together, ready to go. I did see your email, Chris, but I just didn't have a chance to respond last night. I just crashed out and ended up falling asleep in the chair till 1 o'clock this morning. So that was nice, wasn't it? But yeah, I did get your email, Chris. I will send you a response back. Yes, it's all underway. You've got quite a few things on order, actually. Don't forget the AVO, the RAF AVO that you wanted. We've got the Jaguar radio, haven't we? You wanted a DAC 90A. You wanted a Mini Herald. I don't know if you wanted the stripy grilled R707. I can't remember. Yeah, that's right. You can't have stuff that messes the beer taste up. So we've got a couple Grundig things coming for John Turner later if we can get this radio working. Let's pop over to it a minute. So here he is, as we left it, with all its bits hanging off and bits of wire attached to it and all sorts of things going on. But what we did yesterday, I mean, I didn't think it was going to be the transistors. It was more than likely it was going to be a problem with the socket for the ribbon cable, because that's where the upper and lower signal comes from. And if we go on to the schematic, I will show you where we got with it. So this is the area of interest. Now, we were getting this side of the signal, the lower sideband. I was able to trim it using the trimmer, no problem at all. That was fine. Getting no upper sideband at all. And this was just measuring 0 on the base here. And I did check up on this test point over here, test point 38, and sure enough, that was still 0. So there was definitely a problem either in this area or perhaps back to the microcomputer board. So what I did is I got the end of the ribbon cable. I stuck my probe on the end of the ribbon cable, and then I went to test point 38 and there was nothing. Now, this doesn't really give you a good idea of what's happening between that transistor and test point 38. There's basically a via that this line goes through and out to the other side of the board, which is right underneath the ribbon cable. So I had to peel the ribbon cable back to get to the via, and I was able to go from the via back to the transistor to show that that line was in. But when I went the other way, I still didn't have continuity here. Well, I say I didn't have it. I had it intermittently. I had a resistance of about 26 ohms, which should be 0 ohms. And it was wavering all over the shop. So it indicated that there must be a break in this cable. And I can't get the other screen up, I don't think. But basically, this is the end of the ribbon cable. There's 24, I think, pins on this ribbon cable. So I got it under the microscope. I scraped back the insulation on this pin, on this, well, I scraped back down to the copper inside the ribbon cable. I put a little tiny blob of solder on it. I tinned the other end of the ribbon cable that goes into the connector, and I put a little tiny jumper wire between the two. And all of a sudden, I now had continuity between there and the end of the ribbon cable. So at the moment, I've not tested it properly yet. I've not had an aerial on it or anything. So I can tell you that the voltage now at test point 38 on lower sideband is 0, and on upper sideband it's 0.7 of a volt. So assuming that that's enough, because when we look down here, we've got 0 here, but we have got feed coming from this transistor as well. So we got 0.7 basically on upper sideband. So it is switching now. Got a few things to do as well before we can definitely say it's done. Need to test it first of all, but don't forget I turned this little trimmer pot here, this 30 picofarad trimmer. That's the one to set the oscillator crystal frequency. So we made sure we set this one already. I will double check it. So I've still got to go back in and do this. So as I say, I put a little tiny bit of magnet wire on that ribbon cable to join between there and well, if you imagine that there is the tab, and that's the ribbon cable. I basically scraped back here and just did a jumper wire from there to there, and put some UV cure on it to keep it in place and hopefully stop it ever cracking again. That's not to say that none of the others have got cracks in them. It's just that's the only one that I've discovered so far that's got an issue. So fingers crossed, and big fingers crossed, that will cure it. It keeps crackling as I move. It's probably my beard touching on it. My bristle. So that's where we are with it, and I don't know if you can see or not. If I zoom right in, you might be able to see where I've just you can see a little tiny green blob just there, look, on the end. Can you see that? I mean, if I didn't have the microscope, that would be absolutely impossible to do. I would not be able to do that without the microscope. So yeah, you can just see it there, look. See there's a hard green bit where I've put the solder mask on it. Get the glare off of it, you'll see it a bit better. Yeah, just there, look. Little tiny blob. So that was where the break was. But yeah, thanks to Les for his help as well, trying to fathom it out. Hopefully we've got a working radio. So what I think I'll do first of all, before we start messing about with anything else, is we'll hook it up to an aerial if I can. And see if sideband is indeed working. It's going to need adjusting because I have twiddled it, but I want to make sure that we're sorted before we go any further. I've got to go and get my little bit of little cable tie a minute. So, oh, hang on, there's one there. Will that do it? Yeah, that'll do it. Okay, fire in a hole. So let's find a frequency. I need to get the aerial in. Let's get me aerial. Pick that up. If I can remember which one is which. AM external aerial. So that's that one. Put it through at the moment. So I've got to remember with a keypad here. 1, 4, 2. Is that enter? Oh, bum. Ha! 1, 4, 2, 0, 0. And I've got to find the execute button. Is it that one? I can't remember now. Yeah, it's that one there. 1, 4, 2, 0, 0. That one. Right, upper sideband. Oh, hang on. Because I'm not hooked up properly here. No, it seems to be stalling now. What's going on with it? We fixed one thing and there's another problem now. It might be because all these boards are loose, so let's just pull the power a minute. I'll take that wire there off. It's typical, it was working fine yesterday. Seems that when I turn the, what's its name, it doesn't seem to work. That's ground, that's where I need to test the frequency. Still not looking good. You getting some sound issues still? Is it an LED or a neon, Aaron? Afternoon, Jess. Scratchy, is it? Yeah, it might be. Probably this. The old Yeti up. Time to get the Yeti up again. Find a cable for it. I thought it was my bristle scratching it, but obviously not. Now, where is the Yeti cable? That is the question. USB cable for the Yeti. Right off. So it might behave a little bit where I've got it on the bench here and I'm not moving it. So I'm just going to plug the other mic in. I'm going to have to slum it with the Yeti today. Right, let's just add that in. Good old Yeti. Good old Yeti. Yeti saves the day, hopefully. I can add it in here. Right, add input. I reckon we could have problems with a lot of the wires on that thing, you know, that ribbon cable. Turn this one on. We should have scratch-free noise. Yeah. Are we yetied up? Can you hear me? Excellent. Brilliant. Dusty vinyl to CD. Yeah. Turn that off altogether. And turn the one on the camera off as well. Yes, I really thought we cracked that, but we may have other issues. Let me just get this microphone over there out of the way. Unfortunately, it will pick up noise from the bench. So as I'm tapping the bench, unfortunately, it will resonate in the mic. So I'll try not to tap the bench too much like that. So what's going on with this thing then? Is the signal too big for it? Is it overloading it? I don't know. It looks like my my super cap is working all right. Let's plug some power back in again then. I think we may have issues with this ribbon cable. We're gonna have to see, that's that weird calibration thing every time I turn it on, so let's try 1 1 9 8.
Like harvesting them earlier.
Okay. Well, Fergus, here at Great Dixter, do you do much, seed collection, or do you rely more on self-seeders or a mixture?
We do both. We have a big reliance on self-sowers through our borders because that knits everything up and it does the gardening for you. But we do collect a lot of seed as well. And
I don't think there's anything in here that would cause it to stall. No, it should work.
Of course, weather may get in the way, or you may be going away on holiday, so sometimes
there's nothing in there, I don't think, that would cause it to not work.
And hope that you'll get viable seed, and it's pot luck whether that's going to work for you or not. Some
so if I turn the
on the stem, and you'll get success with that.
Encoder,
a lot won't.
That's working now. Okay, so let's try putting the upper sideband frequency in. 1 4 2 5 0. Now the fast slow is there, I believe. Or is it up there? It's there, I think. Yeah, it's stalling. I wonder if this is because I haven't set the frequency up properly on it. Let's get the old frequency counter back out again. I doubt it, but you never know. The Yeti is muted. Yeah. I had to mute it, otherwise I'd have had 2 mics going all at the same time, David, and you know what chaos that causes. Right, let's have a look. There's our frequency counter. Let's get that in. You're not going to go in shot, are you? Silly frequency counter. There we go. And that's the magnet wire I used there to do the little repair. But maybe I need to repair some more of it. Right, so I think, was it that one was mode? Yeah, so mode. Let's turn that one on. So nothing, we've got nothing, shouldn't have anything in AM mode. What's this on? Just trying to filter on that. So let's go USB. Yeah, why are we all over the shop there then? Need to be ×1 perhaps? There we go. 456.465. Now, let me go and get the book of words a minute. I've left it downstairs. That frequency isn't right, but I don't know, that's causing it to stall. Okay, back in the room. I'll tell you, one of the issues with it is that there's no beer gone in yet, so that's always going to be an issue. Right, so look what that frequency should be again. 457, so I'm not far off, look. 457 plus or minus 0.05 kilohertz. The LSB should be 453, so let's do LSB. 452.9795. Yeah, that could be tweaked a little bit. I don't think this is the issue though. I don't understand why when I turn the encoder on a higher frequency it's dropping out, but when it's on the lower frequencies it seems to be fine. Not sure what's going on there. So let's just unplug it a minute. Let's take the aerial out. We don't need that to do the adjustment. Going to need to pop it over again and scarily take the PCB off again with this flex cable attached that I've repaired. I think we're going to end up because you can't replace the flex cable. There is no replacement. You could hardwire it, but that looks shocking, as you've seen from the pictures that I showed you of the other radio that I've got. Let's just undo that for a second. So I need to stick that down there. Reconnect. It's a bit all out in the open, isn't it? So hopefully you can see that. Right, what else have we got to do, Graham? We've got to make sure we haven't got any bits of solder touching the board. Going to have to power it up as well, aren't we? Just to make it even more awkward. And switch it between upper and lower sideband while twiddling the adjustment at the same time. They didn't make it easy, did they? Put my adjustment screwdrivers back here. Wasn't that one? It was that one, I think. Yeah. Okay. Right, let's hook it up again. Find cable. Stay there. Which I'll run over with my chair now. Get off. See what's going on here in mode. Right, upper sideband, that needs to be 457. Thereabouts, that's this one here. Well, that's intolerance. I think it's got to be within 0.05, or we're well within that. Look. So let's switch to lower sideband. If I can find the button again, which is, and that one needs to be 4, 5, 3. Good. Okay. Let's unplug the power again. Carefully. This is tricky to get back in as well. Oh, it's not a great radio to work on this. This side here just does not want to go back in. There we are. Okay. So now we've got the correct offsets. Is that locked in there properly? Now we've got the correct offsets. Let's see if it works now. Joe French, how you doing, Joe? Enjoying this debugging. Your SW55 has only needed caps and 1 trace repair. Yeah, that ribbon cable is a pain in the backside. It's so flimsy and fragile. The end of it was all tarnished, so we had to clean it up previously, but it could be that there's still issues with it. So let's hook up again. on the hoe. That can go off now. Okay, that's working, so let's go 1, 4, 2, 5, 0. So switch this to SSB, let's turn this. No, it's still stalling the oscillator. Yeah. Oh dear. What is wrong with that now? Let's have a think then. So second local adjustment, we've got to use some fancy bit of kit for that, which we've got to build. PLL adjustment. Signal board conductor side. Yeah, so it could be the PLL dropping out, but it's actually stalling the set completely and turning it off. So anybody got any ideas on what the hell that could be then? So we fixed one issue and got another one, which is typical, isn't it? Hi Anthony, how are you, mate? Hi Gio, how are you? Back from potato harvesting, very nice. And Harvey's in. You've got corrupt emails. Yeah, the caps are all here, Harvey. That a mass of nastiness that's caused havoc, no doubt. Super cap, light, so it said the works, this one, but it ain't working. It said the works, but it ain't working. We need to get it working. So I think potentially we've still got problems with that ribbon cable, but yeah, I think that's where we need to investigate next, and that's going to be a bit of a long-winded process, unfortunately. So hopefully you're all in it for the duration. So we'll see if we can get to the bottom of this, because it sounds to me again like we've got a problem with the ribbon cable. So what we need to do is need to pop this board off here. Peel that back. Get all these nice plastic clips off, so we can gain access to the ribbon cable connector, which is, no, actually that's the wrong in it. I need to take this board off first. Come on, Graham, sort yourself out. Take this board off first. There we go. Then unclip this plastic bezel. Come on, monster. We can unplug the speaker. Careful. That's totally out of the way. So now we can see the ribbon cable. Down here. This, I think, is going to be the problem. So basically, I need to buzz out every single one of those connections there back into this board somehow. You've been watching since the start, Anthony. Oh, well, welcome, mate. You didn't catch you clean the connector to the ribbon cable. No, I didn't really, because it didn't look dirty. I did have a good look at it yesterday, Anthony. Could be number 21, power on off. Could be, couldn't it? So let's get my multimeter, which is over here. I really thought we cracked this. I thought I'd sussed it, but I reckon there's more brakes on that. That could be a nightmare to fix that. Let's say it took me long enough yesterday to solder it all back together under the microscope. Right, let's go buzz it. Oh, that's a bit close, isn't it? I'll get it off camera, so you'll be able to hear it beep anyway. I'll stick it on buzzer mode. So how are we going to be able to do this? I need to put something on there and then rest up against it. So I just put that there. I should be able to flip that board over. Sort of. Still have access to the pins. Yes, I have. Okay. So the first one was pin 1. Pin 1 is up here, this end of the board. So if I go from there to that test point, that's fine. So pin 1 is good. Now we're going to find out where all the other 20 odd pins go to. Because one of those is not good. So Derek reckons pin 21, the on-off, might be dodgy. 16. So the only way to sort of find this out is really to go to this schematic and try and work out where the hell they all go. So that's that way up, that's the other way up to microcomputer board. So I say there is, underneath this ribbon cable here, you can't see it, I'm over here, the other a bit further away. Where are you? I'm lost now. No, over here. Yeah, so underneath this ribbon cable here, there's a load of wires. It's stuck there as well. Yeah, so there's a load of wires there. Basically allow me to sort of go across and buzz out this board. But it's all very horrible to try and work on, isn't it? Look at the state of it all. Lysine. I do a multivitamin every day actually, but it don't seem to help in this case. Right, let me think then. So pin number 1 I've buzzed out. Pin number 2 is so what I'm doing is underneath this ribbon cable over here there's a load of wires, so I'm going to go from those wires down to the connector down the bottom here, and if you hear it beep then that's good news. So I'm going to get my little tiny probes on because this is pretty miniature stuff now. I'm just putting these little tiny probes on because the normal tip won't go in there. So pin 2 is the second wire down, so that is that one. there, I believe. Pin 2. That one's working. So pin 3 is the third along from the top. That one there. That one's good. Pin 4 is the very first one over here. That one seems a bit dodgy. Apologies for the noise, but just trying to move the cable, see if that... That one's dodgy. So pin 4 is a problem. Let's get a bit of paper. Pin 4. Not sure what pin 4 does. We'll have a look in a minute. Could be the culprit. In fact, shall we have a look now, just in case that we don't need to mess about with all the others. So let's see what pin 4 does. It's actually easier to look on the schematic. Cheers, cheers, David. See you next week at part 4. Cheers, Anne. Fruos, Vias. So let's see what number 4 does. Where does number 4 go? Let's zoom back out a bit. So 1 and 6. Yeah, see, this is the other ones we've got to buzz out as well. But that's not the ones we're looking for at the moment. We're looking to see what pin 4 does. Ah, here we are. Pin 4 is mute. Now, I'm sure somebody yesterday said that mute was one of the things that didn't sound right on this one. And we've got pin 12, which is cal out. So we've got test point 43 somewhere. Test point 43. Where's test point 43, I wonder? Just so we can go both ways on test point 43, just to make sure it is definitely that ribbon. So test point 43 goes to D48 by the looks of it. D48. Well, so it was test point 43, 47, 46, 58, 40, 57. Yeah, great. There's no test point 46 I can see. But no test point 44. So we're looking for then D48. Let's just see if it's got on the whereabouts on the plan D48 is. D48. No. I don't know why on the schematic it's got like a guide to tell you where they all are, but there's no labelling in the back of the parts list to show you whereabouts they are on the actual unit. Great. Right, D48, D46, 45. .42. Where are you? It's a needle in a haystack job really. D37, 36, 35. D40. I'm getting there. D48. Come on in, D48. Where are you? Unless it's on the other side of the board. Which it is. It's on the other side of the board. Down in the bottom corner here. So does it go down? It just goes to one end of those. So it's either, it's going to be one of those pins. Okay. Right, well, it's really difficult to try and do this on camera really, but we're going to give it a go. We'll give it a go. Yeah, I think that's where it was broken just now. I just want to make sure it's this way, not the other way, so to speak. So if I go, I believe that one's the diode there. D48 is the one on the edge of the ASCII 36. It's that one there. So it's those two legs there. So pin 4, 1, 2, 3, 4. Would have if I had the multimeter turned on, wouldn't it? Where's it go? Yeah, so I should think so. Let's try again. 1, 2, 3, 4. It should be 0 ohms, but it's struggling a little bit. Might just be. I think what we need to do maybe is take this connector off and just give the ribbon cable a little bit of deoxit. Actually, you can have a quick look at my repair while you're at it if you want to. Let's show you what we got. In fact, it'd be good to have a look at this ribbon cable under the microscope anyway, to be fair, because it's not looking great, is it? How are we going to do this then? Prop it up like that, maybe. Stick it down on the deck like that, that's better. Right, overhead camera. It's quite dark. So you can see my little bit of wire I put on there just to link that pad. I coated it with, if it'll focus. Oh, wrong way. Let's go back out that way a bit. Come on, focus, focus. Right, where's my little torch? That's my little torch. Just going to get a bit of light on the subject. Yeah. That's my little repair. But you can see there's a crease all the way along there. So do I have to go in and do every single one? You can see where the ribbon cable's been bent by it being put in the wrong place to start with. You can't really see that on the camera that well. Can you see there's like a double line on it where it's... So the line going straight is where I've put it in. The other one was where it was when I got it. So someone's took this out before. So I'm going to stick my head under the microscope and have a look myself now, but what's Joe saying? The defect yours had was an open wire between the DC to DC converter and Q42. It's PLL low pass filter. Okay. Yeah, I'm going to go in really close with the microscope a minute, so bear with me. Yeah, so you can't... I don't know how well you... If I just zoom across there... what I'm looking at is this is like a piece of tape or film over the top of the contacts. So it looks like these are sandwiched between two layers. And potentially that one's got a break in it there. I it's difficult because you can't really see it. It's quite bright under the microscope, but unfortunately I can't change the... You might be able to see it a bit better. Stick that light underneath it. So can you see there's like a bit of plastic film that goes over the top of the connections. You can see my repair there. So all I've done is I've just bridged that you know, from the plastic flex onto the pad. So I reckon that number 4 has also got issues. It's impossible to tell really because it is intermittent as well, which doesn't help. See, even just flexing that now has cracked my solder mask. So I have to redo that. How on earth am I going to get to all of these then? It definitely looks to be making a good connection to the connector. You can see a good old bite into each part of the cable. How are we going to do this, people? The little scalpel that I used. Oh, you're still with me. Apologies, I thought you were back on that view. John Hughes afternoon. You repaired another one. Yeah. I'm just trying to see if I can peel this film back. That would help a lot if I could. I can't physically see a break because this bit of film is just in the wrong, just at the wrong angle. Hi Lee, how are you? This is why you don't own an SW55. Yeah, I know the feeling. Let me have a think. How's best to do this, Graham? Best bet's going to be to try and tape it down to something so I can have a go at scraping it back. I mean, I'm not convinced that this is the problem yet, really. It could be something totally different, but it's looking at this is the favourite. So if I can tape it to that, perhaps, which might allow me to scrape back a bit. Just turn that light off a minute. Let's get you a bit closer. Right, let's find some Kapton tape here. I've got some thin stuff, I want some slightly thicker stuff really. Let's try and hold it a bit better. That's a bit too thick. It's one extreme to the other. I don't want to really stick anything too strong on it, because it'll end up ripping the cable. So what I'll try and do is get the plastic bit back off the ribbon. There, that makes it a lot easier to work on now. .2010 is an amazing radio, Chris. Can't really beat that for SSB. Right, let me have a look now through the microscope. That might make things a bit easier for me. If I can find it, where is it? There's the tape. So I need to bring it that way a bit. Okay, that's fine. Four is there. Okay. Pin 4 is that one. Can I get that scalpel underneath there? That's what I'm trying to do. Tell you what, I'm in as far as I can possibly go on the scope now. Still can't see whether that's a break or not. It's that tiny. So let me get my multimeter going. So look through the microscopes. Got there. I think that is okay. What a nightmare this is going to be. I think my best bet is to try and scrape this film back. On all of them. I can't do it on pin 1 because I've already... I'm going to have to redo the solder mask on that one now. Hasn't cured very well actually, that solder mask. Still connected though. Just my solder mask didn't set very well. Right, where am I? I don't know where my scalpel handle's gone actually. That would be a damn sight easier, wouldn't it? So I'm going to scrape back just enough to put a little blob of solder on, really, I think. Be careful not to cut through the flex. Okay, get in there. Joe, thank you very much to get you through part 4. Let's hope it's not a part 4. I don't want a part 4, really, Joe. I want a part 3. 3 infinito. Yeah, I can see. I mean, they're all stressed on this bend. They're all stressed. I don't know how many of these I've done. I've only done a few so far, and I've got about 20 more to do yet. This is a bit of a nightmare. So it's almost like 2 layers of Kapton tape with the copper in between it. Well, this is painfully slow. I'm gonna have to see if I can find my scalpel handle, you know. It's very trying, to say the least. So what have I done with my scalpel handle? It's got to be here somewhere because I've used it. Where on earth that's gone to, but it's nowhere to be seen. So it looks like I'm carrying on with the blade only. I have got a sharper blade, but I don't really want to go with a brand new blade because it's going to make it easier to cut through the actual traces. How far across I am? I'm about to here. So I'm nearly halfway. I'm nearly halfway. Dear oh dear. Yeah, I'm looking at it underneath the microscope, Harvey, and I just can't see. I mean, it's stressed all the way along this cable. There's a nasty fold in every single wire where the actual pad joins the ribbon, if you know what I mean. So I'm thinking just to put a very fine bit of solder on the end of each one would potentially reinforce the joints. So someone's saying that maybe we're barking up the wrong tree here. I mean, it could well be. I mean, this cable takes all the signals off of this board into the main processor board, so it's not just the SSB section, it's everything on that signal board goes through this cable. It's strange it's not doing it at the lower frequency, so we could have a problem with one of the reference frequencies, maybe. Okay, so I've scraped off, God, this is making my fingers sore. I've scraped off the packing just on the edge, the paper. I just want to do enough. See, that one and that one look almost broken. Yeah, see, they look like they've got breaks in them to me. Trying to see if I can get you in on the microscope to have a look. Yeah, there we are. I can get a bit more light on there. I mean, I've just scratched those back. You can see that it does definitely look like there is a break just where that joins the... Oh, this camera's not working very fast. It looks like there's a break there, doesn't it? And a break. Yes, just there, there and there. Just it does look like a very fine hairline crack. Micrograms when you give up in less than... What are you saying, Nick? I don't give up. I don't give up, Nick. What are you trying to say? Right, so I think what I'm going to have to do is just clean back all of these now. Where am I? So you can see I've just nicked the edge of the paper to expose the copper. I'm going to try and just solder across all of those. So I've just cleaned those three up. I mean, that end one definitely looks like it's got a break in it, doesn't it? It's too small to get the multimeter tip on even, so I can't even... Because if I put the multimeter tip on it, look, you see this is the tiniest one I've got. It's just too big. That's tiny. So big. Right. What have I got here then? So I'm going to put a blob. I'm going to try and do it under the microscope. Apologies for the wobbly microscope, but let's put a little bit of flux on there. Let's pull off the smallest solder I've got, which isn't overly small. Let's see if I can... Let's get rid of me. Get off. The problem is I'm going to melt through the plastic underneath. I'm not overly fussed about that. That one. That one. Oops. I'll have to wick that off. Okay. So yeah, those three look to have taken very well, actually. And they were the worst ones. I suppose the ones on the end are more susceptible to bending and flexing, aren't they? So if I get you a bit more light under there. So you can see that they are definitely soldered to the ribbon now. Just need to take some of the solder off with a little bit of wick in a minute. But, I think that's going to work. Just want to get some, see if Mrs. Cruncher's got some cotton buds I can steal. I've got some on order from Amazon, but I'm not here yet. Hi Ivan, yeah, it does look like that, doesn't it? Makes the probe look like Godzilla's foot. So I'm going to have a quick look under the microscope, see what it's looking like. Yeah, we need to wick some of that off of there because okay, so I think what I need to do on this now is I need to go and do all of these like that, because I'm just getting flux all over and I can't see what I'm up to. So I'll zoom the scope out a bit and get it. So I can see a few of them at once. It's a pain that I haven't got the scalpel blade, scalpel holder. I'll have to get myself a spare, won't I, for when I leave it everywhere. You know, the only other option is to run jumper wires everywhere, but that looks absolutely shocking. I don't want to go down there. If I've got one that's missing, then maybe I can run a jumper wire, but so that's that actual cable there, that might have been your number 21 that you were mentioning, Derek. Yeah, that's 24, 23, 22. All looked like they had a break in them. So we've definitely reinstated the sideband by repairing those other ones. By repairing that other one. So that one looks okay. There's definitely a fold in it right there. It's got a little break in it there by the looks of it. Little hole. Oh, that one. Is that a hole or is that just where I've taken the stuff off? I've just taken the stuff off, I think. Yeah, that one's got a definite break, I think. There. Let's just use the back of the blade. I don't know if you can, how much of this you can see, but I don't even know which one you're on. Where are we? Yeah, we're sort of in the same area. Just trying to get them done one at a time. Right, time to try and solder them up. Let's see if I can get this in focus a bit better. Apologies for the light. I can't alter the settings on the camera. I should be able to lighten the camera up, but I don't know, there's something up with the software on the camera where I can't physically alter it. So I'm going to put flux all along this. And try not to get loads of solder everywhere like I did just now. Unfortunately it wicks down through the pad, so you definitely won't find a replacement cable. It's like heat bonded onto the board. Chris, I don't even know if it would be possible to do it. No. Poor old lid. I'm going to start over this side as well, so it's not to put too much heat. It's retinning all the pads. I mean, I don't think that's going to hurt. That's all of them gone across, I think. Let's just get a bit of braid. And I'm working on this plastic lid, which is probably a good idea, but then end of the day it's not going to hurt it, I don't think. Yeah, it doesn't seem to be damaging the plastic underneath, which is surprising. I need a bigger tip really, but I don't want to go mental because I don't want to. Certainly couldn't solder with this next tip, but it will wick the solder. Get the solder wick working a bit better. Maybe need to get the smaller solder wick, but hey Cole, how you doing? Look at me go. I haven't even got any beer on board yet. What's going on here? I'm too engrossed in what I'm doing. This is a problem. Let's see. Let's get a little bit sharper for you. There you go. So what I'm trying to achieve is I'm trying to get this excess solder off the ribbon cable. Seems to be working. Right. Doesn't look pretty, but I have no bridges. Follow the flux. That one there still needs a bit of wicking. Just on the very end. There we go. Okay. Right, I'm just going to have another look under the microscope, up mega close. Where's me light? Tell you what, I need a stiff drink after this. Yeah, they've all gone up. It's probably 0.5 millimetre, but they are all joined onto the ribbon cable. The only one I've got a little bit of blobby on is that one there. I'll just touch that a minute just to see if that'll... It's probably going to run right down the thing again, isn't it? I got the iron set down a bit lower, not massively lower, but... That's fine. Yeah. Right. That's that. I did isopropyl it all, didn't I? Might give it a once over with the fiberglass pen as well, just to make quadruply sure. Right, well, it's certainly all nice and shiny. The other thing maybe to do is put a little bit of deoxit in here, in this one. So it's metal contacts, so I think rather than put it in there, I might just put a little bit on the end of the ribbon cable when it goes in, and then it won't get a lot. David, how are you? Retro Tech. It's not working yet. Well, yeah, the SSB is working, Christoph. Got that sorted, but there's other issues. There's other issues. In that we've got problems with this ribbon cable, which I've just gone and soldered across. So only put a little tiny bit on there, that'll stop it tarnishing. Right, it's in. Let's get it back together. See what happens. Just like that, and that one goes over the top there like that. Right, let's zoom you out a bit now because I've gone in a bit close and it doesn't like focusing now, does it? What a game. Did not expect to be messing about with this, to be fair. So what we're going to have, I've got no finger I don't think, but this has been very kindly provided by Mr. John Turner himself, who sent me a nice, very nice box of different beers. And some I've heard of. I've heard of that one, that one, that one. I've heard of that one. I haven't heard of this one before. Cumberland by Jennings. So that's what's going to have to go in me because I'm getting a bit dry here. Babbling on. Do I want to do warranty Yaesu repair? No, thank you, Cole. This is it's a Sony SW55 shortwave. Well, it's multi-band receiver. It's one of these world band receivers by Sony, Sony even. Let's just get this one in the tankard. You need me. Why? What have you got, Cole? Warranty repairs. You want to send it back to one of the service agents. Dids, I'm sorry. There's no finger in the house. I've been defingered. I'm having Cumberland inside me instead. Jennings, there's more to the lakes than meets the eye. So this is from the Lake District, is it? Jennings Brewery. Cumbria, Cockermouth in Cumbria. So yeah, it's up there, isn't it? Yeah. You haven't a sausage about the beer. Oh, very good, David. I see where you're going there. I had to think first, though, before I answer. Right. Let's start putting stuff back together here. So be very careful of this cable because I don't want a repeat of that business. Thank you very much. It's like diffusing a bomb now, isn't it? It's like, look out, she's going to blow. Oh, it's not one on the floor, it's been a little blade. Still got to put the antenna wires back on yet as well, but that's certainly not going to stop the thing working. Oh, come on, get out of there. Okay, right. We should be good for another test run, so let's see if that's done any good at all. I certainly didn't expect to be doing that, and especially not live, but there you go. Got to try it, haven't we? I'll try and show you everything if I can. Right, power. I haven't got the switches lined up, but we'll worry about that in a minute. So let's make sure that it works this way first. Yeah, that's going nice. Right, so let's try higher frequencies. 14250. Enter. No, it's still stalling. It's gone. So it's not the ribbon cable. After all that, what is knocking it out? It works fine down on the lower frequencies. Let's try 12500. Yeah, let's dial on that. Let's try 7100. Okay, AM, let's try it on AM first. Okay, so it's working on AM. So let's turn it to SSB. No. The 7 megs is working. It's like the what am I trying to say? Let's get in a bit closer. It's a little bit like the Yaesu with the wrong voltages on the VCO. So it's working there now. I mean, it should be lower sideband, really, shouldn't it, for that? Sounds like we've got a birdie in there. That's nothing unusual, is it? Let's plug the antenna in again, see if we can actually resolve any SSB. Just shut that up a minute, because I've got the volume sliders not lined up. This is a problem. So when I click this board back in, I haven't lined up the volume slider or the switches. Right, there we go. It's better. Let's try that again. Right. So that is working now. Let's just turn this to 7 megs a minute. So it is working. A 991A and an FT891. Not this damaged, is it? You can email me on that, Cole, by all means. This is working on sideband now. Let's just get that off the screen a minute. I've got it in local at the moment. Let's put it in DX. That is working. No. Let's turn that down a bit. So let's see if we can go to the next band. No, that's just jumping. Some of these radios you can just switch the bands, but some don't know that you can on this one. You've got to physically put the frequency in. So let's try 9. Is that 9? We're still working. Still working on 9 mags. Seems to be working fine there. Just change the mode to AM. Let's just put that one through because it 14 megs. You've got no problem with the warble, Martin? No, that's done, I believe. So let's try 11. 11's working. So 11, top end of 11. Should be some stuff, shouldn't there? interference, that's what there is. Yeah, cheers, Aaron. VCO's on the edge of lock. It could be, Les. That's what I was thinking. It does seem like that. This is what happens with, but it normally if a VCO's on lock, this totally turns itself off though, which is a bit strange. There's something there, but unfortunately, I'm getting an S9 of interference. What was the Volmet station we were looking at last week, where we discovered it was a problem to start with? Can anybody remember the Volmet frequency? So there's 14 megs. Now this is where it was playing up last time. Is it going to play up now? Yeah. So it looks like it's crashing out around 14 megs. So it's like the lower end of the band is okay. Let's go 1, 9, 8.
Questions about what this thing is to be a writer and how it confuses the distinctions between labor and leisure. And this book kind of came out of a complicated relationship to those questions, and also the weird way that I both want to imagine that I'm writing things.
12 megs. 12 megs is working. No, so it's dying after 12 megs. When it gets up to 13 megahertz, it's dying. Anything below that seems to be alright. 5055, 5055, 5045. Let's try that. The band selector goes to a 3 to 8 decoder. Logic might be. Peter Graff, how are you? Blabba Kurzweil. Blabba Kurzweil? What on earth is that, Peter? So let's try Volmets 5055. 5055. No, no Volmat. 6617. No, don't seem to be getting Volmat. Guns. Nah, there's not much on shortwave at the moment. 13264 FM. Welcome, FM. Getting interference there, but that's about it. I think it's stalling up around here. Yeah, so it stalls up around here. So it's in the higher part of the bands it's stalling. Are we looking at bandpass filtering then perhaps around there? Oh, I might have done, Bob. Yeah, you've got to watch me. 5505. I can hear something there. It's there, but it's not great. Still doesn't sound right, does it? It's better, but... Yeah, still not great, is it? On LSB, I thought it was USB for vomit. Let me just check 150 again. Just make sure it's switching across and that wire hasn't pulled off that I did. Yes, it's still 457 dead on upper sideband, 453 on lower. So it is switching now. Yes, it is working. What is the problem with it then? What is the problem? Yeah, you will have to watch the other episodes because, say, I've totally recapped this. You can see over here all the old SMD electrolytics that I've replaced. And someone had put some radio electrolytics in there as well. Done the super cap and also changed to an LED instead of an incandescent bulb for the backlights. And the display is pretty bright now. Yeah.
Empathy and translation feed into this novel.
So that's FM with no aerial whatsoever.
She thinks that people are close. She's just on the verge of separating out as an adult.
What is it? Have we got
particularly from Carmel, but
a
also,
problem with the reference
despite
frequencies?
this great sense of I am that she has, she's just beginning beginning to realise that when you're in love, you don't understand everything about the person you love, and they don't understand everything about you. So we all do this, I think, especially when we feel close to another human being. So she's just looking at the disconnect.
I think that those gaps between people is what runs through this novel in a really sort of compelling way.
Yeah, they were all knackered, Joe. They were all really bad. Even the new ones that they replaced previously were gone. Sergey, how are you? Danish. Shannon Vomit 5505. Yeah, we got that. Sergey, thank you for that.
That kind of desertion impacts the family over generations, really, isn't it?
So he leaves, and Carmel is 12, and it's a great rupture. And the way Carmel is set in aspect, right, when the Da leaves. She suddenly becomes more fully a really literal-minded, no-nonsense, pragmatic, get-through-it sort of person. And all through her life, people say, "Oh, Carmel, you've no imagination." And of course, she can't have imagination. If she allows herself to imagine things, too much will
Now,
happen.
why are you dropping out then, you nasty little radio? Well, it's more naughty than nasty, I think.
How Carmel, being a single mother, affected their relationship, because
So it just seems to be from 13 megs upwards, it's just dropping out for some reason. Check test point 11, 12 and 13, count in binary, or at least all change okay. Processor, yeah, let's hope not. So let's have a quick look. I mean, Les is sort of going down the route that I thought maybe. Joe's saying the transition from one bandpass filter to another. So let's go back to the manual then. Is this a manual or is this just schematic? I think this is just the schematic, not the manual. Yeah, this is just a schematic. Let's have a look at the block diagram, because that's always a good indicator of all the filters, where they are and what bands does what filters. Well, it just says bandpass filter. Into the first mixer, preamp. No, I need to download the full manual like this for it, because all I've got here is the schematics. I haven't got the manual, so see if I can find the manual, the proper one. It's on a go slow because I'm streaming. We want to check this PC for SW55. Schematic version 1.1 service manual. Ah, here we go. Now we're talking. We're in. In fact, this might be a newer version than what I've got here. Uh, 1991. Yeah, I'm not sure what version manual this is. Right, let's have a look. (2002), so this is a newer one. See, cal appears when power is supplied or when calibration adjustment is made. Setting the clock, we don't want to set the clock. Tune in. Scan tuning, memories, we need to get to adjustments. How to set the timer, alarm, sleep timer, disassembly, port functions description. Electrical adjustment. So this is the one that I've just done, which is the BFO adjustment. So that is done. We've got that. So we've got second local adjustment. Now for that we need this little servicing tool made up. It might be that I've got to actually try and build that thing. I'm pretty sure I've got a 2SK193. So we need a 5-volt supply into that by the looks of it, connected up to the frequency carrier. Is that right, or does that... Yeah, looks like we've got to have a 5-volt supply connected to that. So it's like a little amplifier, I believe, looking at it, isn't it? Amplifying the signal off of this test point down here to enable it to be read on a frequency counter. But could I just bypass that and go to that point with a scope? But then saying that, they wouldn't go to this level of hassle if it could be done with a scope, would they? Be useful to make up some circuit boards of all these little servicing tools on all these radios. Make it so much easier, wouldn't it? So yeah, there's a FET in there, so there's got to be like a little tiny amplifier. So tune it to 150, adjust T13 to obtain 55.3912 plus or minus 0.0003. So that's pretty accurate, that. T13. Let's say I've done the BFO adjustment, so that is correct. We've got 457 and we've got 453 on upper and lower sideband. That's okay. So the other thing we can do without any fancy things I've got to make up is the PLL adjustment, because I mean really this could be where it's dropping out. The PLL's dropping out. I don't know, but it's strange that it's totally switching the radio off, isn't it? It's like the processor's switching down. So what we've got to do here, just tune the set to AM 4155 W1DE. What the hell does that mean? Oh, wide. They've got an extra gap in between that. W-I-D-E. You fool. Where's the goat? Where is he? Where are you? Yes, I know. What an idiot he is. So we can look at that frequency there for sure. And we've got the signal side of the board connected up, and that's underneath IC8 by the looks of it. So there's a little test point there. What other adjustments is there? AM IF adjustment. It's not IF, it's not RF issue, and it's not FM VCO. It's not FM stereo issue. So we've done CT1 and CT2. That was the BFO. So it could be this CT6. It's causing us a problem because these little trimmers, they can get tarnished. They're little like silver contacts in them, and they do tarnish with time. And some radios you just cannot do anything until you've changed them. Okay. So I think I can check this one, the PLL. Check that we've got 60 megs on 4155 wide. Can definitely check that one. Let's have a look, see what anyone else is. Let's get me chat up so I can see what you're saying about me. Test point 11, 12 and 13. Counting binary, at least all change okay. Agree with Coop. Could be the input bandpass filter called in this. Bandpass filter selector IC1. You have manual version 1.1. Yeah, there is a system on-off pin on the ribbon cable. Pin 21, I think it was. Yeah. I just thought if this frequency's out, it might be fine on the lower end, but it's dropping out on the higher frequencies. I don't know. Check wave shape and amplitude on test point 48. Let's have a look, see if I've got the zoom out a bit. Alright, test point 48. Test point 28. Pardon me. Trying to find test point 48 here a minute. $39. $47 down there. Where the hell's 48? 46. 47, 45. It's got to be around here somewhere. The hell are you? It's a shame it's not a key to these. You'd think there'd be a key to the schematic just to give you an idea where the living location of stuff is. 44, 43, 42, 57. 40, 56, 52, 59. We're going up. All right, where is it? Can you tell me where it is? I mean wide, yeah. It's off of IC8. Thanks, Bob. Pin 8, IC9. Okay, let's have a look. Well, pin 8, oh, that's IC8. Where's IC9 then? IC8 is a PLL, IC9 is the inverter, which is there. Test point 60, VCO, 62, 54. It's a microcomputer board. No, can't see it. I'm going blind or cracking at one of the two. Grid F14. Okay, let's try grid F14 then. So that's 14. Where's F? So it's down here. No, it's at the top. It's here somewhere. Got a test point 59 on pin 8 of IC8. Where's IC9 then? Is that IC? That's IC9 there. IC8 is the PLL. Unlock is pin 7, which is test point 59. Oh, hang on. Test point 48. 6.275 megs. That's done with trimmer CT6. Is that the one you mean? Test point 48. Was that one you said? Yeah, check wave shape and amplitude on test point 48. Yeah, got it. I've hit it, Joe. Don't panic, don't panic. I found it. It's right in here. It is in your bay. Let's get that on the center of the screen and zoom in a little bit. So it's down here by that crystal. A 6.275 meg nasty crystal. I've had all sorts of problems with those crystals in the past. So test point 48 should be 40 nanoseconds per division, 2.5 volts peak to peak. Now all we've got to do is find on the radio test point 48. That's got to be easy, isn't it? I think not. Let's have a look then. I wonder what that would be labelled as, because it's not labelled as test points on the board. It just tells you what the test point does, basically. So it's coming out of pin 6 of IC8. So let's find IC8, which is down on this side of the board, and it is pin 6. It's the second one up there. See, that says test point 47 there, but they're lying. Test point 48, which is on a pin 6 to the crystal. Okay. Well, I can see the test point now. So let's stick see if I can stick a wire on it to monitor it. Trying to think how I can do this a minute, because my scope I don't think is powered up at the moment. No. So is that the scope? No. Just gotta find my scope a minute. I thought so, but I'll try. No. What I should do is label all these plugs that are all over the place here. That'd be great then, wouldn't it? Be amazing. Those three. I really thought I'd sorted that when I found that problem with the cable. Try that one. I think I tried that one. Yeah, that's the scope. I have scopage, right. Well, can I have something easier to fix?
Poems about the ties that bind people to the landscape.
Right. So 2.5 volts peak to peak. I don't know where and when that is, but let's have a look. Ground it. Definitely got an oscillator there. See if I can get you onto that scope and I'll show you what I've got on that test point. Oh, hang on, let's go. Right, let's have a look where we are. Where are we? So let's go there. So this should be 2.5 volts peak to peak. Valve radios are much simpler. Right, so if I go to that test point now, there's our oscillator. And we need to go into measure mode. Frequency, channel 2 peak to peak, we want channel 1 peak to peak. So it looks like it's around 200 millivolts peak to peak according to that. It's pretty stable. Let's just have a look at what it's saying it should be. Oh, 40 nanoseconds. 2.5 volts peak to peak. 200 millivolts is not 2.5 volts, so is it? 40 nanoseconds. Frequency. Okay, so the rise time says we're looking for 40 nanoseconds. It's sort of around there, 46, 48. Let's put it on times 10 a minute. That'll stabilise it down a bit. Just have a quick look at the probe types. Let's put that to 10 times. Back to measure again. There we go. So now we are at 2.6 volts peak to peak, but with 49 nanoseconds rise time. And I don't know if that alters. It doesn't say what we're measuring that for. That's a 6.275 crystal, isn't it? Okay, you're gonna have to jump in and tell me what your thoughts are on that then, because an IC problem fix anything, right? Okay. Rise time 2.6, and it's thereabouts, isn't it? I mean, it's not. Let's have a look at some of these other measurements just to see if I can pick them up on the scope rather than making up ridiculous stuff for it. Test point 58. Just by Q20. Where the hell's Q20 then? They do not make this easy, do they? FM, S level, ground. Let's see if I can get my eyes in and have a look a minute. The ribbons. It's missing 16.3 volts reference voltage at Q42. Yeah, see, this passes calibration, Joe, but data curve, what does that mean? Curve, AM second local. Detector, AM second local. AM second filter, second mixer. Likes me touching that, doesn't it? This is the 55.39 thing here, I think. Let's go. Come on, frequency. Come, frequency. Frequency. There we go. Oh, channel 2. Channel 1. I want the frequency. It's right. That's 55.3912. It says it should be. It's 55.38. It's moving about a little bit, isn't it? Yeah, that's definitely the second mixer. So we can look at IC8 now again. And that test point underneath apparently is the one that you do, this one here. That's a much stronger signal, isn't it? So that's our reference oscillator. Well, that's the PLL adjustment. So set the set to 4155 kilohertz wide AM. Four one five five. Enter. Wide. AM. Okay. That's what it wants. And it says that frequency should be 60 megs. What? tune set to 4155 kHz wide AM. Adjust CT6 to obtain a 60 plus or minus 0.0005. That's not right. That just doesn't read right, does it? I'm definitely in the right place. Failure in a trace somewhere, you think, Joe? It could be. So, I mean, you would get 6.275 there, surely, because that you're measuring the frequency of the crystal, and you're adjusting that with CT6. I'm wondering if that's a typo, you know. Because if we go to the schematic again, this is test point 48, which I'm probing. Now it says, well, it says test point 47 there, but it is actually test point 48. Or is it? Nothing on that. Yes, I'm getting the reference crystal frequency on there. It's wandering about a bit, but it's ground there. Yes, it is, but when you look at the position of that, so we've got pin 6 of IC8, and that test point is connected to pin 6 of IC8. So if you remember that, pin 6 IC8, test point 48. If I go to the board layout, IC8. So here's IC8. If I zoom in, so pin 6 is here, which comes down here, look, and we've got a test point there, and that says test point 47, 6.275 megahertz. So I'm definitely on the right pin. I've just probed the pin itself, and I'm getting 6.27527. It's floating around a little bit, so it could be that that trimmer's noisy. You know, maybe a tweak of the trimmer might cure our problem. Because I can't get a stable reading on that. I should get a dead steady signal on the scope from that, because it is a crystal controlled. So yeah, test point 47 is test point 48. You know, what the hell. But you know, it's just all sent to try us, isn't it? All sent to try us. So if we go back to this one again. I lost IC8 now. Where are we? There we go. Yeah, so pin 6, that is test point 47 according to this, but it's test point 48 according to the board layout. Crazy, isn't it? So I'm just wondering whether this CT6 10 picofarad trimmer is noisy, which is causing the issue. I don't know. What's your thoughts on that? I'm clutching at straws really, but test point 48. So I've got 2.5 volt peak to peak. Yeah, it does. Yeah, I know. We'd be better to measure with a frequency counter rather than the scope, would it? Yeah. Yeah, that would be good, Joe. I can have a look. Thank you. So you're looking at a circuit. It doesn't show those test points. It does have a TP49 to ground it by. I can't see this blimmin' heart thing's in the way, isn't it? I know there's a way to get rid of that heart, but I can't remember what it was now. I'm gonna have to go in with a Hobgoblin Ruby, I think. I think we'll go in Hobgoblin Ruby now. Okay, I can't take it. I'm gonna have to go in. I'm gonna have to go into the Hobgoblin. My email address, Joe. I think that should come up on screen. Yeah, there we are. Just pop me head up above it. Yeah, a little bit of a mystery, that, isn't it? But some water over my grave then. You used to add block to get rid of the heart, did you? Right, I'm going to nip to Tutloo a minute. I won't be a sec. I will mute the mic though, because you may hear me, even though I'm not carrying the mic on me now. Right, don't panic, I'm back. What have we discovered then? Anything? It's a bit of a pain because it comes up over the writing. It might be because my screen's cramped down. I've squashed the chat right in tight so as I can. No, it pops over the text, doesn't it? Yeah, it's a real pain. So Joe sent me an email, Joe's sending me an email. Very kind of you, Joe. Let's see if I can get into my email now. And while I'm doing that, I'm going to get the Hobgoblin Ruby from John on the go. I do want to have a look at these this board for John today, actually. So I'm not going to dwell on this much more for today. I really thought I'd cracked it when I found that break in the cable, which is why we won't get an SSB. But there's clearly something else amiss. Pretty confident all the ribbon cable is all bang on now. It's definitely switching between upper and lower sideband, that's for sure. But it's something still not right. Okay, so Joe has very kindly sent me some let's see, page 9 for detailed descriptions of the CT6 failure and debugging methods. Let's download that then. Okay, so Joe has very kindly sent me this, so let's have a look together. So this is from Antica Radio. Let's just make sure you've got the full screen and I've not got my silly little head in the corner. There we go. Okay. This is very good. I've never seen this document before, Joe, so thank you very much for sending that over. Right, let's keep going down through. Okay, let's just throw in the tuning steps and all the rest of it. Actually, tuning steps, the tuning step is a bit harsh on it, but .01 could do with .01. This is just really going down through all the functions of it at the moment. It's a big document, this, isn't it? To open it up without breaking anything. Electrolytic capacitors, we've done those, we've replaced them. Supercap, we've done that. Technical solutions to the problem. Self-oscillation on AM, slightly detuned frequency. Self-oscillation. Depends on the track of the S meter that passes exactly under the body of T12 coil of the first local oscillator. Let's go a bit bigger. I'm just reading this, people, so read along with me if you want to. I'm not going to read it out to you. So there's an issue with this track. Is that the issue here, though? I don't think the don't think the pictures are there, are they? Okay, let's have a look here. Right, now we're talking about unlock here, so cal function, joys, and so. What the hell does the calibration thing do then? I'm just trying to see if it mentions it previously. Yeah, this hasn't got the links, as you can see here, unless it refers up to those top drawings or top pictures above. Just get the chat back up a second. I'll have to escape that mode. Lots of chat going on. Hi Andy, how are you? Andy Tobin. Sandra, you're back. It's not finished. We're still in limbo with it. Graham, it certainly is. Yeah, no, it's a great document. So when cal is active, the microcontroller sends to ICA the data to operate the first local oscillator. So it looks like this cal function is all working okay. So surely that would indicate that the crystal's okay, unless it's like marginal. Says match does not happen, the microcontroller will never receive the unlock signal, then after a timeout the microcontroller resets the device. After a timeout, does that mean it turns it off after a timeout? Voltage of 2.6 volts must be present on pin 12. Minimum voltage of 6.3 coming from the DC must be present. So the frequency of 6.275 must be present on pin 6 of IC8. So that's quite a good section to check, isn't it? I mean, it's not failing. It's not failing calibration, though, is it? This is the thing. It's just for some reason it's dropping out. It talks about oxidization on CT6. Yeah. In FM beyond the device resets. So this is what's happening here, but it's not on FM, it's on shortwave AM. PLL. So basically he's saying he's had this problem on FM and he's replaced PLL, well, IC8, which cured it. Tape in, tape out function of the test buttons. Yeah, I mean it's some very useful info in there, Joe, so thank you very much for that. Whether it helps us or not, I don't know. But it could be a bit of oxidation issues on CT6. So let's have a look just to see what see what's going on here. So not failing cow is correct. Hi Martin. Thank you, Sandra. So the reset is, you think that's switching the radio off completely, the reset? Yeah, I will probably need to study that a bit further. Yeah. So let's get the frequency counter on that test point then and see if that makes a difference. Let's get my eyes out of the way. don't know why it's saying this 60 plus or minus 0.0005. It's not 60. Surely not. So we're going with the frequency counter now to have a look at this frequency on here. It should be there. Okay, so let's hit the filter. Oh, can't hear anything now. Have I switched it off? Yeah, so I've switched it off. That's clever, Brian. I'll tell you what, it's a pain in the neck, this membrane, isn't it? I wonder if I can just lay the front of the case on. I can't really, because it won't sit in there. Turn the volume up a bit so I know it's on. Let's try that again. Well, it is out. I mean, that should be 6.275. It's 274, really. Let's get this board off again. I really don't like moving this blimmin' board about so many times. This flex cable is a bit of a nightmare. Okay. So how am I going to trim that and monitor this at the same time? I'm going to have to put a little bit of wire on it, aren't I? I'm going to have to solder a little bit of wire on. So I'm going to trim this and see if that works. If it doesn't, then we're going to have to call it a day for today on this radio. I'll have to have a quick look at John's. I don't even know what the time is, to be fair. I've not a clue what the time is. After self shutdown, yes, it does. It does, Joe. Yeah. Restore full audio bandwidth. See if we can get that out to there. Right, we have a wire. We have a wire attached. Wire on. So there's our ground. Let's get a clip for this one. Let's clip it onto that wire. That's a test point. What a nightmare, isn't it? What a nightmare. Gone, got the chair run over the blimmin' thing again. So we've got plug that in to there. I'm going to turn it on. .27420. Right. So the trimmer is there. Oh, it won't do it. Oh. The best I can get is 6.27440. So does that mean that the crystal is has drifted too far? This is interesting. I'm not having a bad time. I'm enjoying it, Chris. To be fair, I do like to. I do like a challenge. Hi, Ganesh. How are you? Refuse. Yeah. Yeah. So it looks to me like that crystal can't be pulled any further. So it's aged. Now, we have had this problem. We have had this problem before. I mean, I'm right in saying that, aren't I? Because if I go one way with the crystal, with the trimmer, if you watch the frequency counter, let's get you in a little bit closer for those that are not on big screens. So I'm going to trim the trimmer for the crystal. So if I go clockwise, see it's starting to come down again. If I keep going clockwise, it'll go right the way round and then it should come back up again. Oh, it's just dropped right out now. Okay, so let's go the other way then. See, it's dropping back down again and then it's dropped out again. So the most I can get out of it is 6.274, I believe. Yeah. Yes. Joe, it's deleted your message. Yeah, because you've put too many caps in. Sorry, Joe. So Joe's just put this message in, but unfortunately he's put too many caps in it, Joe, so it's just timed you out for a couple minutes. Put your thing back in. So that's what Joe just put in, that we might need to get a data sheet for the CXD 1118 PLL. You got one with the same problems just sending to me. No, Danish, no. So I think we've got a problem with the crystal in that. I wonder if I put my finger on the crystal and warm it up, what it'll do. Or even tap it. No, I mean, it could be the trimmer's not got enough in it, but I don't think it is. I don't think it is. I think that is the crystal. I wonder. I had some of those crystals made up especially for me by a company in Wales. At great expense, I might add. I think I paid 25 quid per crystal to have them made. I think I only bought 3 or 4, I think. Yeah, we got. I did post it back in, Joe. Sorry about that, but the moderator bot will kick you out for too many caps. I've got some of those crystals somewhere. I'm tempted to pop one of those in and see. What do you think? Is that something worth doing? Yeah. It's you can't really see the crystal, can you? I've had one of these before. It failed in the crystal is that one there. Look, just in behind the. Is it an HC9 they call the package? Something like that. 6.275 megs it is. I have got a little circuit I made up here somewhere to test crystals and see if they can be pulled. You can put a bit of capacitance across them sometimes to trim them in, but somewhere I've got these crystals. So let me see if I can find one. Let's try it. I think so. I've got to find it first, though. It's not that simple. Let me just see if I can bring up my database a minute, and I'll see what bin it's in. Drive. Copy of electronic components. Description. Oh, it's taking its time. Data extraction. I don't want to know about data extraction. I just want a crystal. Here we go. Crystal. CB crystals. There it is. I've got 5. Look, I bought 5. And they're in box 10. Excuse me. They're in box 10 apparently. Which is up here. Now, I was going to put these on eBay to pay for the cost of having them made. There they are. Brand new 6.275 meg crystals. Now they asked me all sorts of weird and wonderful questions, most of which I never ever knew what they were. So I've only got 4 left, look. So you think they're 25 quid each. That's 100 quid in my hand there. Craziness. Let's try one. I mean, I gave them the spec of the radio. I told them what capacitors and that it was connected to. It's exactly the same package. I mean, they've done a cracking job. Let's see if this works. Because crystals do drift in time. If it doesn't work, it's coming back out again and going straight back in my box. Because I'm not sticking it in just for the hell of it. Okay, let's get the power off of it. Let's get the desoldering tool going. So I really want to be in and out of this quick. Oh, actually, no, the desoldering tool doesn't work, does it? It's blocked up. Okay. Right, well, I can see the pins for it. So I'm gonna have to use the old solderer suckerer on it. Because my desoldering gun's blocked and I forgot to unblock it, didn't I? If I can find the solder sucker. As usual, the bench has now declined into a massive mess. So I'm over this side working, and it's just below that IC there, right beside the ribbon cable where I've just put that wire. So if I can find my desoldering tool, I might be able to have a go at desoldering it. So what have we done with that? It's over there. Right, let's bump the temperature up a little bit more. Let's go up to 340. I don't want to go too hot on this because you can damage a crystal. Got my eyes on. I haven't got my chat up, so let's get the chat up. No. Yeah, it just might be on the top end of the bands, Derek. It's just too much for it. I don't know. It's worth a trying it. There's got to be something in that circuit somewhere causing it to be a problem. And I mean, it was very specific about the accuracy of that. Now she blows. Right, let's pop the other one in. Whoa, steady. Right, it's in. That didn't take long, did it? Right, let's try it again. That's the old one. It's got a nice new shiny one there. Okay, let's hook the old frequency counter back up. Look at that. Alright, let's see if we can trim that down to as perfect as it can get. How about that? It's worth a try, isn't it? It's worth a try. Right. That's absolutely bang on. That is stable as can be, isn't it? That is a beauty. It's going to cost Clint a fortune, but I'm sure he'll think it's worth it. I'm only joking, Clint. Right. I've left the legs on it for now, because if it makes no difference then it can come back out again, but oh, wouldn't it be great if that was the problem and we've just cracked it. It's got to be something in that PLL area for it to keep dropping out and resetting like that. It's got to be. I need to go loo again, but I am going to fire it up first, so don't panic. So let's go 14. Oh, hang on. No, still doing it. No. And then if I turn it back on again. So it's just dropped out. I put 15 megs in there. It's just dropped out. If I turn it back on again now. It's gone back to 150. So it's still not done it. What a bummer. So although that crystal's marginal, it's not cured it. Time to go loo again. Well, what do you think then? What do you think? You think part 4 will be needed? Gavin's got an old friend called Carl who founded a company making crystals. They were used by NASA for space missions. Wow. Yeah, IC8. From what that other thing says, it could well be a problem. Shall we have a search a minute for IC8? Oh, damn. I know someone that might have one. My friend Adele in the States may have one. The other thing, I do have a radio. It's not a spares radio as such. It's a radio I was going to repair and sell on. One that I need to rewire it all. So we could temporarily pinch the PLL out of that. Right, can anybody remember what IC8 was again? Let's have a look. So IC8, it's a CDX1118M. Let's have a look. Oh, thank you, Joe. So let's go to the go-to place, I suppose, which is eBay. CDX 1118M. I'm sure if Mr. Adele was here, he would probably be able to tell me exactly what was the problem. No, there's no matches found for that at all. Yeah. Doesn't appear that we have anything available. That's going to take me a long time to find that, I think. I'm going to be messing about for a long time with that. Trying to test in bits and pieces. What I need to do is get my other one done so I can use that as a reference. So it also says CXA 1611M. Let's try that. CXA 1611M. No, nothing available on that either. Ah, what a bummer. What a bummer. Cheers, David. If the radio can lock onto a digitally entered frequency, then you'd be wondering if there's another issue rather than the PLL. Oh, good call. Yeah. Yeah, if we turn it back on again. So we're on 150 at the moment, and I can just turn the encoder alert. Turns fine. No problem. Let's go to 12 megahertz. Ah, it's freezing at 12. Oh no, kick back in then. So 12,500. Then it's gone. So it goes off completely, and then when I turn it back on again, it reverts to 150. So it is resetting itself somehow. Well, anybody's got any ideas for that? Drop me an email, leave it in the comments below. Anything you want me to check, anything you think I should check. We've done the crystal, we know the crystal's bang on now. It's absolutely spot on. But we're still no further on. Let's say we can enter a frequency, say 14250. I wonder if it makes a difference if it's in AM or whether it's just happening in SSB. Doesn't appear to be any reception in AM. Ah, so in AM it crashed out altogether. Yeah, that's strange, isn't it? If I put it in AM mode, it crashes out altogether. I wonder if that's pointing back to that issue with the track underneath the transformer. Anyway, I think that's more than enough today. Sadly, I haven't had a chance to get to John's boards today, which is a shame because I really wanted to get that done for him. But I will get that done in the week. That's basically this board here. This one here, which is a frequency counter board for a satellite 2400. John basically wants me to change 2 of the transistors and check the capacitor. There's also a tantalum on there as well, so I'll probably change both of those and do the transistors for me and pop it back in the post. I think personally that there's a similar problem to this as well. It's locking, it's resetting by the sound of it, and I think it probably is that ceramic trimmer there that's causing the problem, or it could be the crystals drifted. But I can't I can't hook this up to test it without the radio, so unfortunately I'm just going to have to do the bits John's asked and send it back to him. He'll have to try it. If it doesn't work, he's going to have to send me the whole radio back. So should be interesting. And I've also got these in for from John, which are exactly the same as the ones that I've got, with the drivers gone in the, well, one of the drivers gone in the headphones. So maybe we can pinch one of my drivers and pop it in these and get that working for John. So that's well, and there's one other thing. John gave me a faulty power supply for a Yacht Boy, and I can't remember what's wrong with this now. I think John said he shorted something out by accident and it died. So you know, maybe that's one to have a look at another stage and try and resurrect. So there you are. That's it for today. Thanks again for the super chats. And the tips. Apologies if I missed any of them, but I've had my head in that radio trying to work out what the hell's going on. But yeah, thanks very much to everybody that tried to help. So Joe's saying it might be time to monitor the digital nets between the PLL and the UP during the reset to find a possible reset cause. Thanks. So give that a thumbs up if you've enjoyed it. It's an ongoing thing. I'm going to have another play with it if I can get a chance in the week. I know Les is probably coming over on Wednesday. So maybe we'll have another brainstorm and see if we can come up with another theory. We fixed one thing, but there's other issues. Cheers, Les. Cheers, Ralph. Send you SDR transceiver. Yeah, no worries, Ralph. Brilliant. So cheers all. Have a good one. And have a good week. I will see you next Sunday. I think. I've got this one Sunday that I'm not going to be able to make, but I think I'm all right next Sunday. Anyway, cheers all. Have a good one, and I'll mute this mic and try and sort my other one out. I need another new connection on the end. So bye for now.